Hey there, welcome to Curious Minds, the show that pulls back the curtain on the science that shapes our world, one breathtaking story at a time. I'm Ashwath, your host, speaking to you from a quiet corner in my room where the rain's tapping against the window like it's trying to get in on the conversation. Today, we're diving into something that feels straight out of a thriller, but trust me, every bit of it is real. And by the end, you'll never look at your inbox or your DNA the same way again. Ready? Let's ease into this. Hacking used to feel distant. Someone steals your credit card, you cancel it, life goes on. That was cybersecurity, guarding the digital fort. But hey, biology didn't stay in the lab. It went online. DNA isn't just inside us anymore, it's sitting in cloud drives, research databases, sequencing pipelines. It became data. And once something becomes data, it can be stolen. Suddenly, stealing isn't about draining bank accounts. It's about rewriting life itself. That's cyberbiosecurity. The wild frontier where digital compromise meets biological systems. A hacker doesn't need a gun or a virus in a vial, they just need your password. Yes, it has become that simple. Theft evolved from wallets to the very code that makes insulin work, or tells a cancer cell to die, or maps your family's ancient migrations. One click and the stakes aren't your weekend shopping, they're humanity's health, our trust in medicine, the fragile balance of scientific progress. We're not guarding information anymore. We're guarding what makes us human. Alright, now, let's talk about the attacks that actually happened. The ones that slipped through the cracks and shook the world awake. Picture this. October 2023. You're curled up on the couch, maybe sipping tea, when your phone buzzes with a security alert from 23andMe. Attackers accessed around 14,000 accounts via credential. Stuffing and scraped data affecting about 6.9 million users, I repeat, 6.9 million users. This didn't mean full genomes or full health reports for everyone affected. Instead, what leaked were pieces of information connected to the DNA relatives feature, things like ancestry breakdowns, relationship predictions, and profile details such as display names. These were exposed because they were linked across family tree connections and user sharing settings. And the strangest part? People didn't realize their relatives' data could be exposed because of their choices. Privacy turned into a group project, one nobody opted into. No confirmed misuse has been reported so far, at least based on current public information, but experts warn that the risks don't appear immediately. They unfold downstream. If this kind of data falls into the wrong hands, insurers could use genetic tendencies to quietly adjust premiums. Employers might screen candidates based on health predispositions they were never supposed to see. For ordinary people, the danger is psychological as much as practical. Fear. Fear of how their DNA might be used. Fear that joining research studies could put their future at risk. And for scientists, it cuts deeper. When trust in genomic privacy cracks, the whole research pipeline slows down, collaboration stalls, data sharing tightens, and breakthroughs take longer because the system suddenly feels fragile. 23andMe released an action plan and was later fined £2.3 million by the UK's Information Commissioner's Office, failing to protect UK users' genetic data. Parts of the exposed dataset surfaced across dark web venues. As victims told reporters, it's like your genetic family tree got posted online without permission. These real incidents jolted us, but the next warnings? They came from scientists, not attackers, trying to show the world what could happen. Rewind to August 2017 at the University of Washington. Tadayoshi Kono and his team aren't villains. They're prophets running a controlled academic proof of concept. They encode malicious digital code into a strand of synthetic DNA. Harmless, lab-made material. When sequenced and processed by vulnerable bioinformatics software, it triggers a buffer overflow and executes code on the analysis computer. No pathogens, no release. Just a demonstration that biological material can carry executable digital malware. Here's the easiest way to visualize it. It's like hiding a computer virus inside a poem, and the moment someone reads it aloud, their laptop gets hacked. If this vulnerability were ever targeted, an attacker could mail tainted DNA to labs, sequencers would run it automatically, software could be compromised, data stolen, results altered. It's a risk to research integrity, to medical pipelines, to infrastructure. MIT Technology Review's headline captured the moment perfectly. Scientists hack a computer using DNA. Then jump to 2024. Ben-Gurion University in Israel. Another controlled demonstration. Researchers showed that maliciously crafted DNA orders could bypass screening checks at gene synthesis vendors, tricking systems into unintentionally producing harmful viral or toxin sequences that appear harmless on the surface. Think of it like a mislabeled package. On the outside, a harmless sequence for a classroom experiment. Inside, instructions that could assemble a toxin if nobody looks closely enough. No real attack happened, but the message was unmistakable. Strengthen the supply chain now, or someone else will exploit the gaps later. These academic alarms weren't doomsday fantasies, they were warnings, and the world listened. Industry bodies and standards groups began tightening sequence screening. DNA order vendors strengthened their scanning systems. Sequencing and bioinformatics software received long-needed hardening updates. Traceability tools and watermarking emerged. Dark web monitoring services expanded specifically for leaked genetic datasets. IGSC companies applied stricter screening to prevent the synthesis of harmful sequences. If cyberbiosecurity is a new battlefield, these people are quietly building the armor. So today, we've walked from real breaches that exposed privacy and trust to academic demonstrations that revealed just how vulnerable our biological infrastructure could be. To the early shields being forged to protect the future, the shift to cyberbiosecurity, it's here, but so is our power to secure it. Here's what keeps me up and fuels me. When the code of life becomes just another file, the question isn't only who holds the keyboard. It's whether we're building a world where that person chooses to heal, not harm. Thanks for joining me on Curious Minds. I'm Ashwath. Stay curious, stay vigilant, and hey, next time that urgent update email lands, maybe give it a second thought.